So we can actually utilize these double angle formulas to derive, I'm not going to go through that process, but we could use it to derive what we call our power reducing formulas. What power reducing formulas do is give you a way to take a trig function that is squared and rewrite it as one that is not squared. So there's your sine squared, would be written as 1 minus cosine 2 theta over 2. Cosine squared theta will be 1 plus cosine 2 theta over 2. And tan squared theta is actually, if you think about it as tan as being sine over cosine, reduce the 2's, and you get 1 minus 2 cosine theta over 1 plus 2 cosine theta. So these are very much needed when you get into rather difficult integrals in Calc 2 that involve trigonometry, some trigonometric integrals. Because of that, I'm going to take you through a power reducing with sine in this video. That's all we're going to do with it. And I'm going to give you, as an extra credit on the test, the other one. So actually, I'm going to take you through cosine, and I'm going to give you sine on the test. If you can show me all the steps, do it on your own, show that you did it on your own on the test, I'll give you some extra credit points. But, so let's just see what we do with these power reducing formulas. So basically, if I have cosine to the 4th power of x, so that's cosine x all raised to the 4th power. What I want to do is come up with an equivalent expression that contains no exponents greater than 1. All right, so how do I go about doing that? Well, the first thing I would do, and again, this comes up when we have to take integrals of higher powered trig functions in our Calc 2 class. So basically, I can rewrite cosine to the 4th as cosine squared, right? Because like anything squared and then squared again is that anything to the 4th power. So that means I can plug in my cosine squared power reducing. And this is what? It's all over 1. That's all over 2. You actually have to square, so squaring a binomial is something you have to do a lot. So let's square that. When we square that, of course, we get a 4 in the denominator. When I square 1 plus cosine 2 theta, I square the first term, I get 1. Then 1 times cosine 2 theta doubled is going to give me 2 cosine 2 theta. And then I square cosine 2 theta. So of course that gives me cosine squared of 2 theta. So all I did was square the 1 plus cosine 2 theta. If you're not sure where that came from, just FOIL out 1 plus cosine 2 theta times 1 plus cosine 2 theta. All right, so my issue here is I still have something with a square, but before I do that, I kind of want to simplify this down just a little bit, and I'm going to turn that into 1/4, right? 1 over 4, 2 over 4 becomes 1/2 cosine 2 theta plus 1/4 cosine squared 2 theta. So I just removed all over 4 and put each term over 4. Okay, well, I still have something squared, so I need to use the power reducing formula again. Just copy these down. Because remember, your goal is to have trig functions that have no exponents greater than 1. All right, what does cosine squared 2 theta look like? Well, if you go to your formula, it's 1 plus cosine 2 of theta. That's 1 plus cosine 2, but my theta in this case is 2 theta over 2. So now I have 1/4 plus 1/2 cosine 2 theta equals, well, 1/2, 2, that's going to, not equal, sorry, plus 1/4 times that. That's going to give me 1/8 of 1 plus cosine 4 theta. Okay, I'm going to clean that up just a little bit more into all my terms. I'm going to distribute. One fourth plus 1/8 is 1/4 plus 2/8 is, I'm sorry, 1/8 plus 2/8. 1/4 is 2/8. Anyway, it's going to give me 3/8. So I was only able to bring these two together to get 3/8, and I'm done. So again, I'm not going to put a regular problem on the test with this power reducing, but you need to see it. You need to recognize it. You will use it if you're going on and taking Calc 2. So you will be required to know these formulas when you are doing, I believe it is chapter 8 of your Calc 2 class. It'll come, you know, in the first half of the semester. That's it for power reducing.